Türen ist zu, dann sollten wir loslegen, ne? Okay. Hello, everybody. Don't worry in the back. There's seats up front. You don't have to stand. Anyway, it's nice to see people having interest in this topic. So welcome for the talk, Eclipse for Teaching Systems Engineering. So we have a plan. We have a vision what we can do with Eclipse and what we can move in systems engineering. So, and we'd like to share this plan with you and hope to engage a few people to share our vision and to help making it happen. So systems engineering and Eclipse, there has been a lot of talk about that lately. And the focus seems to be Eclipse Con France in Toulouse, where Airbus sits and the PolarSys activities are steered from. So, but why is that interesting right now? So there are a lot of things happening in systems engineering today that basically create change and some movement. And this is something that we want to take advantage of. So systems engineering typically deals with big things, rocket science, planes, trains, whatnot, right? So big corporations are there and they're trying to make that happen. So they have complicated processes, fulfill standards with 5-digit numbers which are hard to remember, and they buy really expensive tools from IBM, from STRL and other organizations. And so it's like a big thing. And the small guys are typically left out. So there are a lot of suppliers in systems engineering, but these suppliers typically don't drive the whole thing. And when they think about doing stuff like that themselves, they feel that they're too small to achieve something. They feel they're too small because the tools are very expensive, and implementing the processes and getting the certifications is also very important. So I'm more on the tooling side. I'm going to talk a little bit about that. Andreas a little bit more on the process and standard side, and is going to talk a little bit about that. But so that's the situation in systems engineering. And again, Eclipse started to create some activities there. Who here knows PolarSys? Okay, half of the people here. So PolarSys is an Eclipse working group. And it's also the name of a tool, an Eclipse-based tool for systems engineering. And there's been actually quite a bit of activities. Anybody knows Topcase? Okay, so Topcase is now pretty much PolarSys. So they changed name and basically revamped the whole thing. But so Topcase has been around for, I don't know, a number of years. Then you see that I also put like a number of other tools on here, like Rodin, which is their Eclipse-based platform for formal modeling. There's Papyrus here, which is actually part of PolarSys for SysML and UML modeling, and some other projects. So there are already a number of components around in the Eclipse ecosystem for system engineering. So, so what's the problem? So these are used in some pilot projects at places like Ericsson or Airbus, and there are also small companies using that, but not very much. If I look at Eclipse and what it achieved in the area of Java software development, that's pretty amazing. So, and we're wondering, can something like that also be realized in the systems engineering world? So here's our vision. So we want to make Eclipse-based, model-based system engineering so accessible that we capture SMEs, so small and medium enterprises, and academia, in addition to industry. So we see like a lot of activities in industry, like Ericsson is putting millions into Papyrus right now. Virtually, they're putting like millions of euros or dollars, I don't know, into Papyrus to really use it internally. They really have like a strategic interest in Papyrus being successful. But small companies cannot do that and try to get students and universities engaged. So there's really not that much excitement about it. We want to change that. So we think it's a good time to change that, simply because the business models that dominated the last 20, 30 years have changed. So on the left-hand side, you see like the old business model of big tools. Not only systems engineering tools, also in other areas. So with commercial tools, you typically have a vendor lock-in. So if you buy their IBM Rational Tools or STRL Skate or something like that, you're basically logged into this tool ecosystem. Service providers have some access. In fact, the big vendors do need service providers. But these are typically limited to using, I don't know, some scripting or this or that to customize it. But it stops somewhere. The vendors control the tools. We want students to use tooling so that they basically get educated in the proper way to be productive in industry. Access to those tools is typically limited. Sometimes the vendors provide some access because they want the students to know those tools, but it can still be tricky. Long-term support. This is actually one of the reasons why Airbus started to look into open source. Anybody here knows how long the lifetime of an airliner series is? Like the A310, I think it was. Any idea? Yeah, longer even. I think it was planned for like 40 years. When it was a success, they extended it to 50. I think now it's like 70 years. Similar situation you have in the rail industry. So really, really long time frames. No vendor, even if they promise you that they basically keep the tools available for 70 years, are you going to believe them? They may go bankrupt, they may get purchased, change their strategy. So that's quite a big risk. On the other hand, commercial tools typically have a high quality. And this is one of the reasons why they're so popular, even though they're very expensive. So the new open source-based business model, the users control the tool. The users who are willing to take money into their hands, like Ericsson with PolarSys, they're the one in charge. And everybody has access. There's really wide access. Open source tools can be expensive if the community is small. So there's a very strong incentive for successful projects to expand the community as quickly as possible, to give them the support to be productive with them, because the more people use it, the cheaper it gets eventually. And one big problem is that the quality is low unless they're really big. I mean, tools like Firefox or the Linux operating system today are fairly high quality, but even look at something like OpenOffice, which is very popular, and still as far as quality is concerned, there are problems. So getting high quality open source, I think, is a big challenge. And addressing that is a big step in the direction of making that successful. So, okay, I was trying to set the stage here and tell you like a little bit of what this is all about and what we're trying to do here. So now I want to just briefly introduce myself, and Andrea will introduce herself and tell you why we think that we can do something here. So I started the Eclipse requirements modeling framework. So it's a tool in the Eclipse ecosystem for managing requirements. So there's a user interface, there's compatibility with industry tools, which is very important. And requirements in systems engineering are typically the starting point. Requirements are very important. You attach them to contracts, you use them to track your progress, you use them to write your acceptance tests and so forth. And it's one part of systems engineering, but it's a very important one. So with this, I'm going to hand this over to Andrea so that she can take over and cover the next part of this talk.
So my name is Andrea Hermann, and I'm a trainer for software engineering and also teaching at universities. And one problem that I often have is to motivate people to use software engineering methods at all, because they like to just programming. And so heavyweight methods are not very good for selling software engineering. Therefore, I'm very interested in lightweight methods and lightweight tools that can easily be used. So I'm currently reading and rereading the ISO standard 29110, because this is a lightweight standard. Sounds contradictory. Their motivation was that they found out that small enterprises and small teams do not use standards for several reasons. And they did a survey about this topic, found out that quite some small companies, they need to use standards, probably because they deliver software to larger companies, but they don't use standards for several reasons. And some of these are, they have no resources for the organizational overhead for doing this. Maybe also someone who can understand this special ISO language. And because of bureaucracy, it's very complex. You must write a lot of documents, which partly are redundant. And they also found out that examples are something that people wish to support them, because this abstract standard description is not so motivating and it's difficult to apply them. So if people see it applied to an example, this makes it easier to apply the standard. Oops. Okay. So, and this standard is relatively new. It is made for very small entities. That means teams or organizations which have less than 25 members. And it covers project management and software engineering, all phases of this in a lightweight way. So there's no much overhead. And we are currently a team of about 6 persons. We are 2 of them who think about how can we deliver such examples and develop course material so that people can more easily use this standard. So what we have is an Eclipse-based tool for model-based software engineering, which we can use for the modeling of the requirements and test cases and the complete cycle. And what we want to develop is the documentation, to have a tutorial how to apply the standard, and also a simple case study. We will see this on the next slide. It will be a small car, and the requirements for this car described in the structure of this model. So this all together will bring together, we hope, a community of persons who apply this standard, starting with industry users, service providers, and also academia, who is amazingly not very interested in standards. The universities develop their own methods and their own standards, although ISO has already invested a lot of thoughts in how to develop software. So this is our case study. We still haven't decided whether it's rather like this or this, or you will see. But it will be a small toy example, so no complex real car, but rather toy example. And what the ISO standard wants us to write is a requirement specification, which can be simply a list of pretext requirements, a data model, well, that's probably known, a validation report, traceability matrix, which can also be very simple. Traceability is a complex topic, but as we have already simple requirements list, this this traceability is also easy. We have relationships between requirements and relationships to test cases. And then also change requests are used here, so formal change process. So we will start with this. This means we start with the requirements, and when we have all these requirements for the project, then we can continue with the next steps in the software engineering. This project now is a master thesis, so a student is investing a lot of time in developing this example.
So now I get to talk a little bit more about tools, because we are at EclipseCon here, so I think you want to hear a little bit of what's going on in the Eclipse world with respect to these ideas. So I'm going to introduce in a minute the toolchain, the Eclipse-based toolchain that we want to use for this project. But before I do that, I want to whine a little bit and talk a little bit about this project, openETCS. Anybody here heard about that? Okay, it's a research project. It's financed by itea, which you may or may not know. So it's a joint European project. And it's industry focused and driven by Deutsche Bahn and other organizations like Alstom. And the idea is to create a model of the onboard unit for a train control system. So there's this so-called ETCS, Standard European Train Control System. So if you want to get into a train here in Germany and go through Belgium to France and whatnot, that's possible because of ETCS. That's basically the underlying standard that allows that. And the problem is, this standard today consists of a stack of Word documents, which has all kinds of problems. There are inconsistencies, ambiguities, and so forth. So the objective of this project is to create a model of this system and to make it available for free in the hope that vendors like Alstom, Thales, Siemens, and so forth would use it to have a more solid foundation for building their control systems. So that's the idea. And a lot of frustration in the project came from the fact that they wanted to use Eclipse-based tools, but they just found too many gaps. So you see that they actually adapted the requirements tool from the Eclipse ecosystem. But then you see this line. This is all tools that are not open source. So for example, they decided to use Skate for code generation, for design modeling, and so forth. So what I want to show you with this picture is that there are definitely holes in the Eclipse ecosystem for big projects. So our goal, our objective is to say, no, let's not start with a super safety critical Europe-wide system that is like a very, very large challenge, but let's start bottom up, not top down, bottom up. So our goals for this initiative are very modest, and you can see that on the next slide. So this is basically what we plan on for our very first milestone. This is what the student that Andrea is supervising is going to work on. He's going to pick a very simple but engaging case study, like a little rover that's autonomous. Cool. That's something that you can let run around in the classroom, whatnot. We're going to do requirements management following the 29110 standard, which was, as Andrea said, specifically designed for small organizations. And we want to do this in a solid fashion with properly documented artifacts in a self-contained fashion, so that if organizations, universities, small or big, come and basically say, we want to look into this tooling, that they find something that they can understand, that's comprehensive, that's good enough to evaluate, and so forth. This is something that we've seen was missing from most of the Eclipse-based system modeling tools. So this is basically our first milestone. And we hope to achieve this by February next year when the student finishes. And this is basically what we plan as the initial toolchain. First show of hand, who knows the V model for systems development? Okay, it seems that almost all know that. So you basically have the development from the requirements all the way down to the code on one side, and then you have the testing of the corresponding elements on the other side. And of course, you're not working down here and back up. It's not waterfall, but it's iterative. But this is basically visualizing how the various components fit together. So this is tentative. So we plan on starting with requirements. We need to do some system modeling, some simple system modeling. And we're still debating whether Papyrus and using UML SysML is the right tool for that, or whether we simply use eCore, which is very mature. Who knows eCore here? Okay, also almost everybody. So that's like the modeling language of the Eclipse modeling framework. So eCore is very nice because you can take this model and you can generate code from it. You can generate test stubs from it, which basically takes care of the source code and unit testing here. But that basically covers already a lot of the components of a minimal system development environment. And the acceptance testing here on the upper right, that is something that we realize also using RMF. And in a minute, if time permits, I'm going to give you a very quick demo to give you an idea how the whole thing could look like. But this is basically what we want to get in the long run. A minimal, solid, completely documented system development environment together with the case study that is complete and realized with this toolchain, and which is cool to boot. So, and once we have that, then you can basically start to doing more with it. So for something like what I just described, the train project, the ETCS project, it's far too small, doesn't scale, so you would have to include new components. You may even want to exchange like whole blocks of components with commercial ones. So we want to keep it very modular. You could take the whole thing and do a certification or even a tool qualification, which again is something that you need when you do safety critical system development, and so forth. So we think when we look at systems engineering with Eclipse today, there are a lot of really, really good pieces, but there's nothing holding them together. So our goal is to get them together and create a package that makes them usable. And again, we do not want to reinvent the wheel, so we do not plan on developing new Eclipse components. We also don't plan on developing new processes or anything like that. We're just taking from the Eclipse ecosystem what's good. We are taking from the process world what's good, like the ISO 29110 standard, and really making it accessible. That's our goal. Okay, so with that, I basically covered most of what I wanted to talk about. Now I think we do have time for a very quick demo. Here's one screenshot. This is something that we did experimentally, where we connected requirements with a Papyrus model. So, and you can just create the traceability with drag and drop. I just want to show you how the whole thing can look, how this, basically I want to show you this little tool chain, the pieces that we have, but only like little extracts from it to give you an idea what we're talking about. So this is the requirements modeling framework, and well, this is not a rover, this is a traffic light system, but as you can see, you can work like almost like in Excel, where you have your individual elements, and you can basically create new requirements if you want to. So I can create a new sibling here and basically say nobody must come to harm, whatever. So it's just textual requirements. Now, what we did also, we created a model, a data model of the domain. So I think that's the eco model I was talking about, and we should have a diagram. Here you go. So you can see that we have here a domain model of our controller who controls two traffic lights which have states. And what's like really neat about that is, let me go back to the eco model. So typically you only have like a tree representation of that. But if you now want to create some kind of traceability, so for example, here we have the requirement, the controller has a trigger for propagating to the next state. That's like this function. So you can create a traceability simply with drag and drop to this one here. And let me just make it like a little bit more bigger, like that. Okay, so now you basically see that we have a traceability from this textual requirement to our data model. So, and then you can explore it from here, you'll be able to navigate it and so forth. So you can basically follow from requirement to model element, from model element to code. EMF has the ability to do code generation. So you can, you need the generator model for that, which is this one here. So you could basically tell it to generate the model code, so it generates in Java your domain elements. It can create even a graphical editor if your application needs that. And it can also generate the test code. So again, going back here, we had our requirements here. We had our system model, our data model in eCore. We generated from it source code stubs. So of course, you still have to provide the implementation for that, at least in this scenario. We generated from it the unit testing stubs, which you also can have to implement to provide your tests, but the stubs are there. And the last thing is we want to have some kind of acceptance tests, and I'll show you that one as well. So if we go here to the requirements, you see that I put somewhere, let's see here. I got a specification for testing. You see, this is just like sample stuff. I mixed Rover and traffic lights, doesn't matter. So you have the safety requirement here. The Rover detects stairs and turns around if encountered. So we can initiate a link to this here and complete the linking. And now you see that we have a connection between this safety requirement. Let me just make it like a tidbit bigger here. And the corresponding test case. You can select the test case here and even see the results of the manual test for version 1, version 2, and you could add more tests there. So this is like a very, very quick overview of the tooling that at this point we intend to use for covering a minimal system development environment. So it was very quick. I hope this made sense to you. Just so you know, we've been working on the Eclipse-based tooling for quite a while. And again, this was eCore. You can use a different modeling language like SysML, UML. We actually did like a pretty sophisticated integration with a formal modeling language called Event B, where you even had like color highlighting in your textual requirements of elements that were modeled in the formal model. So it's actually fairly easy to customize the whole thing and to support the processes that you want to have. So with this, I want to close. So we think that this is pretty exciting, both for small companies who really want to take advantage of all the tooling that's available, but didn't really find the right approach to it. We think this will be pretty exciting to academia, and we hope that this will be exciting for you too. If you're into Eclipse-based tooling for systems engineering, this could be an opportunity for you to bring your tooling in here. So if you want to engage, and we hope that you want to get involved, the first thing would be to join us in the online discussion. So we have a website set up for that, which is growing. All the content is licensed under the Apache 2.0 license. We didn't use the Eclipse license because we found the Apache license a little bit more favorable for artifacts versus licensing code, but that's just a technicality. And last, we also are going to have like a BOF session where we will basically work on the case study and really work out, basically wrap up our sleeves and get some real work done. But we invite everybody who is interested in this topic to join us here, to bring in their ideas, to make suggestions, to make improvements, and to do some brainstorming to move this project forward. Last, in addition to the student doing this, there's also at least one application pending of another research grant. So should that get accepted, then we'll have some more funds available of driving this project forward. So with this, I'd like to thank you for your attention so late in the day, and we are open for questions. Thank you.
I actually do have one question. I'm actually from Airbus Defense and Space, and I'm working in the area of systems engineering, and in particular with defense tooling now. I really like your approach, bringing the system engineering to the universities and to the small, medium enterprises with your approach. What we were seeing was from what I understood, really focusing on software systems. Do you also have already experiences and means by technology to also cover other aspects of system engineering? I mean, looking to the spacecraft domain, there's just much more than software. Software is a very important part of the spacecraft, but there's so many other domains that have to deal with system engineering and cross-domain dependencies.
Absolutely.
What is the experience there?
Okay, so two things about that. And number one, the standard, the 29110, has two different profiles for software and systems engineering. So maybe you can say like a little bit more about the ISO standard. That's the one thing. And the other thing is we encounter that all the time. And simply because we are focusing on systems engineering, but then basically the tooling, you're totally right, only covers software engineering so far. So one approach that we use for small systems is simply to model the API. But for the train project, for example, we really have to do some hardware-in-the-loop testing. And the problem is we didn't find a solution for hardware-in-the-loop in the open source ecosystem. So there's definitely a need for something there. But for small, non-safety critical systems, you know, basically using a clear API and some mocking for the tests, that's all we can do. Do you want to say something about 29110?
Only this, it is a standard for software engineering, so systems engineering is not covered, but there are other ISO standards where they have as well as software specification as a system specification and have both of them.
If you have like an interesting project, like a little remote-controlled rocket or something like that. Other questions?
Unfortunately, they're always big projects. Not really a showcase for such tools which are very comprehensive.
All right.
Unfortunately, no.
Cool. I think there was a question here.
Yeah, I'm wondering a bit about, I guess, does the scope of this example include maybe pedagogical framework guideline type thing for the actual teaching part of it? So if one were to extend this example or to replace something, then is there a guideline about whether that's a good implementation that comes out in the end, or in terms of like teaching quality or something?
I think this is a nice example for teaching, because finally we will have a result, a little rover, that we also can test, so cover the whole software engineering cycle, and then have the little car running on the floor and doing its test cases. So this is the idea to have, I think it's also motivating for requirements engineering, that students see that they will use the requirements later on.
If I can add one more thing to that, more from the technical side, of course we are aware that the materials that we're producing here may not be usable as is for everybody. So we already established an infrastructure for the documentation, for all the artifacts, that is specifically extendable. And in particular, all the materials are there. And we used actually LaTeX and build scripts to produce the documentation, excuse me, with links to the artifacts that can be used. And it's fairly easy to mix this up with your own teaching materials. So if you want to use this as a foundation for teaching materials, but you feel that pieces are missing that are outside the scope of our project, you can basically create your own content and basically seamlessly integrate it with our content.
I guess I was wondering more from the other direction. Is it within the scope of your project to guide, for example, small tool developers providing teaching materials?
The result of the project will be teaching materials, so use the slides and use the examples. So first we do the case study, and then there will be teaching Yes, yes, that's the idea. So also the teaching material will be open source, and you can use this, modify it, and also contribute if you like.
Especially contribute. Does that answer your question?
Yeah, I think so.
Okay. Other questions? Well, if there are no more questions, enjoy the beer. Thank you for your attention. Because I think now it's time for the Stammtisch or something like that.